Good afternoon, everyone, and welcome to our webinar titled Banking on AI. I'm Julie Johnson, and I'll be your moderator for today. Before we begin, I'd like to just review a couple of housekeeping items. First, we've allotted time at the end of the webinar for questions. You can submit a question by simply typing it into the question box located in your GoToWebinar toolbar. Secondly, if you'd like copies of the slides presented today, just send us an email at info@micronotes.com. That's info@micronotes.com. All right, I think we're ready to begin. It's my great pleasure to introduce our panelists today, Dr. Luis Perez-Breva and Devin Kincaid. Luis is a Micronotes advisor with a PhD in electrical engineering and computer science from the Massachusetts Institute of Technology. For nearly 2 decades, Luis has researched, practiced, deployed, and taught entrepreneurship and innovation worldwide, developing expertise as a serial innovator and entrepreneur both in the laboratory of innovation and in the classroom as an outstanding innovation educator. His work, research, and entrepreneurial experience spans technology innovation and the application of artificial intelligence to solve multidisciplinary real-world problems that disguise as big data, yet escape traditional scientific and analytical methods. Our second panelist today is Devin Kincaid, a serial entrepreneur and founder and CEO of Micronotes, an interview marketing automation company based in Cambridge, Massachusetts. So without further delay, I'll turn the time over to Devin and Luis. Take it away.
Thank you so very much, Julie. This is Devin Kincaid. I'm here with my friend Luis Perez-Breva, and we're here to talk to you about banking on artificial intelligence. I'm super excited to be here, and now that the introductions are complete, let me give you a synopsis of how you're going to spend the next 20 or so minutes of your life. We're going to give a brief introduction, primarily around Luis's experience on what artificial intelligence is and what it isn't, how it should be applied and how it should not be applied. Then we're going to talk a little bit about keeping the I in AI, keeping the intelligence in artificial intelligence. And then, as you know, Micronotes is a commercial company, and so we have to apply these technologies in real-world settings every single day to help our customers win. So we'll talk about actual banking applications and how it's in production today and what kind of results we are seeing. So for those of you who are not familiar with Micronotes, Micronotes is a cloud-based marketing automation company based here in Cambridge, Massachusetts. We leverage fast interviews and artificial intelligence to solve the digital engagement problem, which can be summed up as follows. People today are banner blind, which means they don't see banner ads for the most part, and they don't click on them. And even if they do click on them, they're faced with loading landing pages and navigating landing pages, and the entire process is very unproductive, actually. And so that is a big problem. If you can't engage your customers, you can't learn from your customers, you can't help your customers. So we are doing everything we can and making a lot of progress on the digital engagement front. So, Luis, welcome again, and it's great to have you here. And I have to tell the audience, Luis is going to see the King of Spain, and I think that is so cool, and I'm so very proud of you.
Thank you.
So Luis, for our audience who's not familiar with maybe with the topic of artificial intelligence, other than perhaps what you see in the movies, take us back sort of 25 or so years when your professor, Professor Winston, defined AI as the study of computations that make it possible to perceive, reason, and act. So unpack that for us a little bit and tell us, what is artificial intelligence? What was it then, and what is it today, and what is it not?
So thank you. So we start about the time when Patrick Winston made this remark, it had been 25 years of the field, and the field started with the lofty goal of actually copying human intelligence, reproducing human intelligence. Since that remark, what has evolved a lot is what readers may be familiar with, which is the push for big data, analytics, and so on and so forth. So we've become incredibly good at making mathematical or producing mathematical algorithms that can actually solve incredibly complicated tasks or that can actually detect incredibly obscure patterns. That's what we've done. But the problem that Patrick Winston puts forth here remains actually the biggest problem of artificial intelligence, which is when we try to reproduce human intelligence, one of the things we realize is that humans do not just go about computing their life. They don't just go about sensing and then storing data and then looking for patterns in the afternoon. What they actually do is they weave that data seamlessly into a story. So the field has evolved. The last 25 years have taught us a lot of how to use math to sense and to detect patterns. And what we're doing today is trying to figure out how to make those patterns, how to make sense of those patterns in the context of a story. Much like humans, we'll actually see a lot of data, and we'll try to make sense of it. Not so much because there is a lot of data, but mostly because that data is telling a story, or is the result of a story.
So that's a really interesting angle on artificial intelligence, bringing what have historically been mathematical computations into the context of human experience and story. So say a little bit more about the story aspect of artificial intelligence, because I think that's something that our listeners would be interested in.
So one of the things we would really like computers to help us do is interact much better with us, actually.
Right.
So you face today an enormous amount of data. It would be great if that intelligent computer were able to translate it into that particular kind of story. So stories, like the same we've been reading since we were kids, actually start with a problem. They don't start with the data or with the statistic we need to get, but they start with an objective, a problem that needs to be addressed. There's a cast of characters, there's a cast of situations that sort of emerge and evolve with time. Right? So in the context of AI, the difficulty here is finding the right problem that makes sense in the context of a market, for instance, and then weaving backwards from that how to make sense of the data so that we can have continuous answers to that story, or at the very least guide the people that are actually needing to interpret that story,
right,
to be able to kind of make decisions after it.
Right.
It isn't so much the computer making decisions or replacing humans, rather it's empowering them with a story that's hidden in the data.
Got it. Yeah, I think that's a really elegant concept of that bridges, the mathematical computational side into the human experience, which is so deeply rooted, anthropologically into stories, and stories are what attract us as human beings, and certainly what sell on the television. All right, so let's take another sort of another layer down into the actual computational side. So when we look at computation, so tell our audience, these are we're going to talk about classifiers, and Micronotes uses classifiers to try and figure out who we should start a particular story with, and let those customers finish that story with us. So we use big data analytics algorithms, and we classify people as to their probability of purchasing a particular product, a mortgage or a platinum credit card or an auto loan. So let's talk about what is a classifier for our audience's benefit, and why do some classifiers, as we see from this chart, which is called a confusion matrix, and it's aptly called a confusion matrix, I think, because I always get confused when I look at these things, but if you work hard enough, you can figure it out. So what is a classifier? It's a computation of sorts, and why do classifiers produce sort of different performance results? What's going on in this chart?
So classifiers, to take it just a step back, a classifier is one of the basic building blocks we use when composing these stories. It's a computer algorithm that's been trained with data to recognize two distinct classes or three distinct classes of information or people or whatever you're classifying.
Right.
So this classifier you see in here is actually what you're seeing here is the performance of a classifier, not linked to the story, but linked to how is it that it's actually dividing the data. So what you see is true positives, which means data we know to have been of the correct class and the classifier classified correctly, and then data that, such as the false negatives, for instance, that the classifier thought were of one class, and then it turns out they were from the other class. So there is some degree of noise or error we expect in the data, and that's what this translates into.
Right.
There are different classifiers because different performances, because every problem has a different nature to it. It has a different statistical distribution and so on. So you need to train different classifiers, and they perform differently all along. But the other important thing, which is linking it back to the comment on the story, is that this is just a classifier. This is just a mathematical tool. It's a hammer, if you want.
Right.
The question then remains, which of these, or by looking at this table, what one can actually do is tweak the classifier to address better the story you want to do. For instance, if you would rather have fewer true positives, right? Yeah. But at the expense, or actually you would have, you would be okay with fewer true positives, but you would never get a false negative, for instance. That would be something that you could actually tweak the classifier to do for you, and that largely depends on the story you want to do afterwards.
Exactly. Exactly. So is it fair to say that a classifier, I mean, in English, is if you were trying to create a basketball team and you decided that the only characteristic we're interested in for this basketball team is height, and so as people who wanted to try out for the basketball team sort of walk up to this classifier, that person measures their height, and then if they're tall, he puts them over on one side of the court, and if they're short, below a certain height, he puts them on the other side of the court. And at the end of the day, you know, you've got a classification done. Tall people, short people. Presumably the ones that the story we're trying to tell is we want tall people on the basketball team. Is that a fair characterization in the simplest terms?
That's a fair characterization
in the simplest terms. Okay. So for our audience, you know, that's the way to think about a classifier. It's a mathematical computation that enables that classifier to look at a given subject and classify that subject based upon their attributes into one box or the other, one side of the court or the other. So great. So that's helpful. We use those all the time, and we get great performance, which we'll talk about in a minute, from using those classification algorithms. So Louis, we've been talking for a long time together about the evolution of Micronotes, and one of the things that you cautioned us was in the application of artificial intelligence. And I think we sort of summed it up on this slide by saying that you do want to use machine learning and AI to inform your audience selection. You probably don't want to use AI to try to do what's on the right side of the screen, which is if you ask Siri today, I think I have alcohol poisoning, what do I do? She'll respond with, you know, 7 liquor stores fairly close to you. That's not a very intelligent response. So can you say more about sort of where, you know, where artificial intelligence is really hard to apply? That's an obvious example of where it's difficult. But why is it so difficult to apply it over on that side?
Well, Siri is trying to solve a very, very big problem, which is no matter what you say, to have an answer ready for you.
Right.
Right. So that's a very big problem. That's really like a lofty goal. It's equivalent to the lofty goal of artificial intelligence. And today I would say the technology is not yet there to be able to solve every single instance of a problem, as Siri would like to do, or as many other systems would like to do. But we don't need to go all the way there to actually have artificial intelligence applied today. And so one of the things that's most important that you guys did very well over the last several years is try to figure out what's exactly the problem you want artificial intelligence to solve for you, and how is that problem related at the very end with the data that you actually have. And so once you narrow down the problem sufficiently so you understand what you really want the computer to solve, then it becomes incredibly easy, or increasingly easier, to develop classifiers, a sequence of classifiers, a story effectively, that can be meaningfully addressed with a computer. Siri is trying to some degree, become the expert for everything and replace a call to a friend, right? You are here, you're trying to build more of a sequence of arguments that would make it easier for a marketer at the bank level to be able to tease out certain products and be able to kind of address their customers better, which is a very different objective. It's not a one question, it's multiple questions.
Yeah. Just out of curiosity, what is, this is a big error. This is a big mistake. What do you call that? Is Siri lacking context, or does Siri just really not understand the question but thinks she does?
It's tricky because there are probably numerous algorithms behind this query in particular.
Yeah.
Query in particular is probably trying to parse a normal sentence into something the computer could understand, and then trying to find the closest match in terms of either a web search or search for stores or search for something else, and trying to solve all those problems at the same time. And in this particular case, a simple not or a simple word change would have changed the meaning of this sentence. So from a pure computational standpoint, this kind of an error may not flag as that big from the computer standpoint. Right. It is huge to a human that actually understands the story and for whom the language that's spoken there is just a tool.
Right.
But computers are only now starting to understand language very well. Siri is particularly good at it, but the context is incredibly important.
Right. Clearly. maybe in this particular case, Siri was working for these 7 liquor stores. Great. So that's a great segue into this topic of keeping the I in AI. So we know that this is a really hard problem for this conversational problem is really difficult for AI to solve. If you tell Siri my favorite fruit is mango, she'll respond oh, and then if you ask her what do you think my favorite fruit is, she'll say I don't know. So this is not intelligent AI. This is just so these kinds of conversations. So if you take a step further down into the world of trying to sell financial services, is if you ask Siri, what do I ask someone if I want to sell a mortgage, you'll basically get a search result that'll tell you, here are the 25 questions to ask your mortgage lender. It's just wrong. It has nothing to do with what I'm asking, and because she's lacking context. Turns out humans are actually very good at the dialogue game. You can sit down with a piece of software, and you can actually envision and create an entire conversation with all of the nuances of human experience. So I know this is a little bit difficult to read, and we'll blow this up in the slides that we send out. But just to give you an example, if you target some customers for a life events interview, for example, and ask them if any of these life events are looming large on your horizon, whether it's buying a home or whether it's having a child or sending a child to college or retiring or whatever the life event might be. It turns out that conversation gets pretty complicated pretty quickly. So if you're buying a home, if you respond that you're buying a home, the next question might be from a practical business perspective, geez, what's your timing? Well, if the answer is it's within 6 months, that suggests a slightly nuanced response. You're not going to immediately answer that by saying, well, gee, do you want to apply for a mortgage right now? Well, wait a minute, didn't I just tell you that, it's probably 6 months off? Instead, there's a nuanced question, great, can we help you with either of these financial services, whether it's a mortgage or home insurance, which are the 2 products that this institution offers. If the customer says mortgage, well, then it's another nuanced response. All right, are you interested in a pre-approval, which is an appropriate response to someone who's 6 months away from buying a home. So all of these, all of this contextual information and nuanced response information is very well contained in the human mind, and can be brought into code fairly quickly using tools to create dialogues. And I think just to build on Lewis's previous commentary about, well, which problem are you solving, I think is a critical question we're certainly always asking ourselves. And actually, the problem that we're solving using AI is not how to maximize, necessarily how many people click or how many people accept an offer, or what the how many leads convert to a sale, but the combination of those things, really the number of offers that are converting to a sale, because it takes time for customers to consider an offer, and we want to make sure that we're getting them to consider the best offer for them. So, for example, if you look at this this chart, you might automatically say, oh, well, the percent of leads offers accepted, those are leads, 22%. Wow, that's a much better number than the 10% below it. Well, maybe. That is for all propensities, but if we select a high propensity audience, we're going to have fewer offers accepted, but we're going to have a lead to conversion rate that's significantly higher, almost 4 times higher. And that increases the ratio of percent of offers converting to sales. So in practical terms, what does that mean? What that means is, given the choice of making making mortgage offers to 1,000 people, you have the choice of getting 220 leads, chasing all those down and getting 1.7 sales. Or you can make mortgage offers to 568 people, get 57 leads, and get the same number of sales. That leaves you to talk with the other 432 people about something that's more important to them than having a mortgage conversation. And that's important because this is all about optimizing the experience, not only optimizing revenue for our customers who are financial institutions, but also optimizing the experience for the individual customer. They have a finite amount of time. They're only going to answer so many interview questions. So different problem, as Louis described, different optimization problem. We're trying to solve a different problem, essentially, with this technology. So if we put it all together in practice, just to bring you all home, if you combine machine learning and artificial intelligence by using the data we both have from our customers, as well as the data that we receive through the interview process, which informs our targeting system, you can select an audience that makes sense to be selected. They have the right characteristics. They should be playing basketball because they're tall. And you can combine that with the beginning of a story, I think, as Louis very beautifully described, which you can then enable your customer to finish. Do you have 5 years of mortgage payments remaining? That's the beginning of a conversation of a refinancing event. Let your customers finish the story for you. And if you do all of that right, then you get more mortgage sales at lower cost, because you're chasing fewer leads, but more of them are converting. And there's real cost to both your customer base as well as your internal operations to chasing low-quality leads. So I think we've got about 5 minutes remaining. I think we'll wrap up at this point and open the floor for any questions that might have arisen during our brief chat. Julie?
Thanks, Devin and Louis. It's great to have you. So at this time, our audience members are welcome to submit any questions they might have. The easiest way is via the chat box, which is located in your GoToWebinar toolbar, which may have become minimized during the presentation. So we'll wait a couple seconds to see if any of those questions come in.
Well, it looks like we did a pretty good job, Julie. Wait a minute. We have a question.
Let's see. Okay. Question just came in.
How do we select an algorithm for data analysis? Wow, that's a great question. Louis, do you want to take that?
Sure. So there are endless numbers of the algorithms one could actually apply for data analysis. The question really is, what would you want that data analysis to do for you? And that's a tricky, it sounds like a tricky question, or a kind of bouncing back the question. But in reality, given how many things you could do with the data, you might as well worry about what would you do once the analysis comes out right. Because it turns out that most people focus so much on the analysis, they forget that once they get the numbers, they haven't thought out at all what is it that they will do once they actually have the result, the pattern, or whatever they want. And so they end up applying inadvertently two algorithms, one for analyzing the data and another one for deciding what to do. Normally when you combine those two, not only is the algorithm easier, but you can actually understand that you don't need perhaps as much data as you thought you needed. So as far as selecting an algorithm, if the question was posed in a technical context, I would say keep a small data set outside, try a few algorithms, see what you get as a result, but don't get obsessed about the performance of the algorithm. Rather focus on the performance given the question you want to solve it. You start with, which is not unlike your table earlier.
Start with the problem.
Yes.
Start with the problem, and then test different algorithms to give you the highest performance against that particular problem. Great. Any other questions? Let's see, we have one. Yeah. Couldn't this also be used for non-financial institutions? That is, other companies where their customers or members have to log in, like Verizon? Oh, that's a great question, and actually sort of for you. Well, actually, you have some very interesting experience in telecom. But yeah, so the answer is certainly it can be, and this basic tool set applies to both figuring out who to talk to, who to start a story with, and enabling you to engage with those customers very effectively, as well as let them finish the story, as we talked about earlier. So sure, you can absolutely apply the technology to non-financial institutions.
And I think that the listener has a point. Once you get or perfect the idea of how to interact with your customer through a conversation, then it doesn't so much depend on the product. Of course, you need to tweak for every product, but you should definitely be able to apply these to any context where you would like to discover what the customer might actually want through a conversation, and building and allowing your customer to build a story, not just to finance service.
Yeah, absolutely. I think the other piece the final piece I would add to that is that one of the great things about about using human intelligence for sort of the story prompt side and the dialogue side is that there are pockets of deep subject matter knowledge around the world, and that deep subject matter knowledge is so very important when trying to construct. We already saw how machines can fail miserably at at fairly simple things, but when you get into deep subject matter, boy, there's an expert really understands how to nuance a conversation so it feels natural, it makes sense. Geez, I never thought of that. That's a great question. I should think about that. So enabling the platform really enables you to use and leverage all of that subject matter expertise, whether it's about fishing lures or telecom or mortgages. It doesn't make any difference, but there are pockets that now can get the leverage, because you can have this conversation with thousands or millions of people, and you can not only do it not only do it today through your login, but we're also now bringing this technology out onto the broader internet, where you can actually conduct prospecting interviews just out on the internet to enable stories, wherever you can buy ad space. So that's a pretty exciting development as well.
Great. Well, thank you, Devin and Louis. In the absence of any additional questions, and looks like we're out of time, just want to thank all of our audience members for joining us today. Again, if you would like to receive the slides for this presentation, just go ahead and email info@micronotes.com. That's info@micronotes.com. And also, if you're interested in learning more about innovative digital marketing solutions, specifically for financial institutions, you can visit the Micronotes website and blog at www.micronotes.com. So thanks for joining us today, and we'll see you next time.
Thanks, Julie. Bye, everyone.
Thank you.